Welcome guys. Today we are going to try to solve a local minimum question. We have to find the local minimum of f. We're given with fx equals to x square plus 1 upon x square and gx equals to x minus 1 upon x, and x belongs to real numbers between -1, 0 and 1, and we are given hx equals to fx upon gx. So first let's write down the equations. X squared plus 1 upon x squared upon gx is x minus 1 upon x, correct? So we can write x squared plus 1 upon x squared as x minus 1 upon x the whole square plus 2 upon x minus 1 upon x. So simplifying this, we have x minus 1 upon x plus 2 upon x minus 1 upon x. Easy. Now we are going to differentiate hx to find the local minimum. So dhx upon x equals to, we have x minus 1 upon x will be 1 plus 1 upon x square minus, using chain rule, 2 upon x minus 1 upon x whole square into 1 plus 1 upon x square. Easy. So now we are going to simplify this equation a little bit. So first we have 1 plus 1 upon x square in a bracket x minus 1 upon x whole square minus 2 upon x minus 1 upon x whole square. 1 plus 1 upon x square common. Let's clean this up a little bit. So we have this equation 1 plus x 1 upon x square into x minus 1 upon x whole square minus 2 upon x minus 1 upon x square. So now we have to simplify this a little more so we can solve and find the value for dh upon dx. Okay, so now we can write this equation as 1 plus 1 upon x square upon x minus 1 upon x whole square into x square minus 1 whole square minus 2x square upon 2x square upon x square. Sorry. And finally we have hx equals to 1 plus x cube or x square upon x minus 1 upon x whole square into x to the power 4 x4 plus 1 minus 4x square equals to 0. So we're going to have to now we can write this equation as x square minus 2 whole square minus 3 equals to 0, which implies for local minimum x square equals to 2 plus minus under root 3. So x square equals to under root 3 plus minus 1 whole square upon 2, which implies x equals to under root 3 plus 1 whole square upon 2, that is root 3 plus 1 upon root 2. So keeping this in mind, we have, let's try to visualize this on a number line. To do that, we have a number line with 0 here, this is negative 1 and positive 1. So root 3 plus 1 upon 2 lies here, call it a maximum point, and root 3 minus 1 lies here upon 2, and root 3 minus 1 negative lies here. finally root 3 minus 1 upon root 2 upon 2 negative lies here. So now we have x equals to root 3 plus 1 upon root 2. So we can write 1 upon x as root 2 upon root 3 plus 1 into root 3 minus 1 upon root 3 minus 1. So equals to root 3 minus 1 upon root 2. So finally x minus 1 upon x equals to 2 upon root 2 equals to root 2, which implies root 2 plus 2 on root 2 equals to 2 root 2, which is the answer. So the answer to this question is 2 root 2, that is option B.